Hello, everyone, and welcome to our Tech Talk podcast. Today, we have a guest that you probably know from the community. He is Shamser, one of our core developers. He has been working on a number of components in HPCC for the last several years. But in this particular edition of this podcast, we want to cover what he's doing today, or he's been doing for the last several months, working on our HPC Systems cloud journey in getting our HPC Systems platform ready for public clouds. Ready means a lot of things. We have been seeing how others in the core development piece of the community have been working on components on Thor. We have covered some of Roxy. We have covered some of the dynamic aspects of cloud. But one of the most important aspects of cloud is the way that resources are provisioned in systems. And the fact that the way you provision your resources and the way you make those efficient enough will create a significant difference in the way your system will cost you as it runs in the cloud. So Shamser has been doing a lot of work in this area, and he's been also doing a lot of work around the user interface of this particular feedback from the system. It's giving the user information, valuable information that they need to be able to make these decisions and provision the systems correctly. So hello, Shamser, and it's a pleasure to have you here today. So, Shamser, can you tell us a little bit of what you've been working on for the last several months in this area?
I've been focused on the costings, so it's actually ongoing work. What we're trying to do is provide information to the user who executes work units, information about how much that job is costing to execute. So this is specifically useful in the cloud environment where resources are you can allocate as much resources as you want or as little resources as you want, and it would be beneficial for the user to know if their job is taking, exactly how much it's costing. So
that's interesting, and you brought an important point there because you said per work unit, and I didn't mention that, but now the system as a system, a Thor, doesn't exist until you're trying to run your work unit. So you're going to be providing costing back based on what that work unit will require as type of resources? How does this work? And is this something that comes after the fact, after the work unit ran, or is it information that is provided even before it runs?
This is on the information provided. It should be on the actual cost. So it's, that information is only available after the work unit executes. So that will include all the pre-execution time plus the actual processing time and the use of various resources such as storage and data transmission. So all those would be factored in to the costs. There's a lot of flexibility. Well, there should be in the future where the user will be able to select much wider range of Thor cluster sizes for their particular job. So if they know, exactly how much it's costing on a, say, a 16-node cluster versus 100-node cluster, they can decide the best option, whether it actually makes sense for that particular work. So.
So you can, like almost everything else in life, you can trade off time for resources, right? You could say, well, I run this work unit in a 200 nodes cluster, and it takes me 5 minutes, or I run this work unit in a 20 nodes cluster, and it takes me an hour. So are you going to be helping them decide which one of these makes the most sense from a cost perspective? Because at the end of the day, it's an optimization problem, right?
Absolutely. It's actually a very complicated problem because there are so many options. Traditionally, in a bare metal type data center, the users had very few options. They had maybe 2, 3, 4 different sizes. So they could start, look at a job and say it's a big job. I'll put it on the big cluster. In the cloud, the options are almost endless. You can choose a different type of resource the different amounts of memory, different amounts of CPUs, various other resources that are available. So if you look at that, all the different types of machines available, plus the different types of clusters available, the user is very difficult to work out the optimum.
Okay, yeah, I can see there are so many combinations there. I think I used a bad term because I said, well, it's just an optimization problem, but it's not a simple optimization problem. It's a very complex one.
Absolutely, absolutely. And sometimes it may be that you can actually execute a job very quickly and save a little bit money, rather than executing it slowly over a longer period of time. So using fast CPUs versus slower, cheaper CPUs might make more sense. So in other times it might be the other way around. So we would like to provide the user the information that would be useful in helping them decide how best to configure the future cluster for the full job. So
that is very interesting. So, but how do users look at this information that you provide? So, do they need to go into the logs and take a look at are you going to be saving this additional information in the logs, or is it? Do you have a user interface for this?
Okay, the first phase, we are looking to provide just the actual or estimate on the cost of executing a job, the cost of a particular activity. So every single activity that's executed within a job, that will also have a cost. So those costs we'll be providing that within the metrics, so the graph metrics. So
it will be initial watch. So yeah, all of this will be just there at their fingertips, not need to go and grab logs or anything like that. Okay, okay, that's yeah.
And so that cost will be available. And in the future, we are looking, the analyzer will be examining the entire job and actually advising you, this is a type of machine, this is a type of cluster that would be the cheapest to execute the job, or the quickest to execute the job. So they will, the work unit analyzer will be able to provide information on that.
That is very cool. So, and how granular are you going? Is this, you said work units, but I could see how you could decide to optimize an entire work unit by partitioning that into different subgraphs that you will run in different type of hardware, right? You could say, well, this particular subgraph that needs this big sort might run more optimally in this configuration. This other one, which is a project with this transformation, will run more optimally in this other configuration. So are you going to go deeper over time into this subgraph type of optimization, or is going to be, for now, just a global work unit optimization?
It's a great idea. Having the individual parts of the graph executing on different sizes is a great idea. I mean, if you start on a big sort job, initially you need a lot of resources, but as you end up near the end of the job, you need less resources.
Go down. Yeah.
So I mean, it's not something that we've discussed in the team, and it involves beyond just providing the information. So it's something that I think we've touched on within the team, but I don't think we've made a decision on this yet. But in the future, when we have that information available, I'm sure it's something that we'll be working towards. So while the job is executing, adjusting the resources.
So and how does this actually work from the standpoint of using it? So I find the user, and I have this work unit, I go and run it. and then I go to ECL Watch and see the costing of that work unit. And now I need to run the work unit again tomorrow, so I use that costing to change the configuration manually myself, or is it going to be something that the system will provide for me? Will the permission system provide a Terraform template, or I don't know, or new deployment strategy, or new configuration, or something like that that I don't need to worry about?
In the early stages, it will be manually configured. So the costs will be provided as part of the Helm configuration, the YAML file within the YAML files. So that's our initial first versions. Beyond that, we need to think about how best to simplify getting the costing information from the cloud provider. So there's the different cloud providers do this all differently. So we'll need to look into how possibly we can actually provide that information automatically without needing the user to configure it manually. But I've looked into this, and it's not straightforward because the actual resources available that the cloud provider provides and the pricing is quite complicated.
Yes,
and
it
would be,
because you need to take not just the brackets that they provide, not just the price, but also brackets for the price, depending on utilization. Many times, sometimes they have discounts that are specific to customers. So when you start looking at all of this, it is not an easy equation. It's not just, oh well, you pick this instance size and then you get this price and multiply by the number of units in time, right? It's a lot more complicated than that.
Yeah. There's various other subscriptions, and you can buy a set number of machines for a year, and so it is complicated. So we'd like to let the user configure this in. Hopefully it'll be a one-time thing, one-time effort, and all the users can use the same cost table. But I don't. In the early stages, we don't intend to provide that. There's too much work involved in that.
Another question, and maybe this is an idea, perhaps it's not, but so if you have, I assume that as we continue to move to the cloud on this in this HPC systems initiative, we will have the ability for the user to select different configurations for their systems when they run the work units, right? And that might mean that they will have different templates of sorts, right? They say, well, I have this template for 20 nodes, this one for 50, this one for 300, whatever it is. So as you run these work units, are you planning on providing feedback on which template would have been more optimal for this particular type of work unit after it ran?
Yes, that's our longer-term intention. So that will be provided as part of the analyzer. It'll look at all the information and suggest, possibly this type of template would be better, and it could. Yeah, this is exactly our goal. Yeah.
That sounds like nirvana. Yeah, it's quite interesting and useful.
Yeah. Yes. It'll look at the peak memory usage. It'll look at the storage. It's how the disk is being used. It'll look at the type of activities, the data transfers, and it can look at all that information as a whole and then suggest the best way of executing that job.
Absolutely, yeah. So tell me more about the analyzer. Now, you mentioned the analyzer a few times. So what's the stage of the analyzer today, and what is the roadmap there? What's going to be providing to us?
Okay. The analyzer at this stage, we are reporting a number of different issues on Thor jobs, and they're mostly SKU-related issues. It's just Thor at the moment. There's no Roxy support, so that's our intention. I'm actually looking into providing support for Roxy. So that's our future goal.
Well, Roxy is a different beast, so adding the support for it is going to be also yet another pretty significant amount of work, right?
Yes, yes. I mean, it's the way Roxy works is different. The type of issues are different. Some of the statistics that are generated are different. So we can't take the same rule set and just apply it to Roxy. We need to examine each rule and see which one that makes sense, which ones make sense, and the different types of issues that Roxy jobs or queries face. So Roxy is ongoing now. I'm actually in progress, and hopefully end of Q3 we should have some kind of Roxy support.
That's very good news. Yes. So if I'm a user right now and I go and download 7.8 latest or 7.10, what do we do? What do I get? What can I start testing? What can I start playing with?
Okay, it's the analyzer executes automatically after a Thor job executes by default. So as of 7.8, you will have that analyzer execute automatically. And within the messages section, within ECL Watch, you will see some analyzer messages shown. So that happens automatically, and there's no configuration, nothing extra that needs to be done by the developer. That information will be just provided. The issues, there's a number of different types of SKU-related issues that are detected and reported on as of 7.8. We also have a command line tool. So some historic jobs, 7.6 jobs, possibly pre 7.8 jobs, they can be analyzed by the analyzer. So, and information issues reported on terminal. That's the basic starting point that we have for the analyzer.
So today the analyzer will give you just information in those messages. And how about the costing tool? So if I go and download 7.8 or 7.10, do I get access to that or already on the graphs or the?
Yes, yeah. It will not in the graph. It will be shown in the messages section.
Okay.
So with all the other warning messages, compiler errors, and any issues, the messages section of ECL Watch, it'll be shown there. It will be recorded in the work unit. And if you want to run the tool manually, you can execute it using the WooTool info argument. And it's basically WooTool info, the work unit you want to analyze, and DALI server, and that will report any issues.
That is very useful. And again, back to the costing, the cost piece that you were describing initially. What's the status of that? If I download again and install 7.8 or 7.10, do I have access to the work unit cost already, or how limited it is, and how much of this still needs to be worked on to get a final solution?
Okay, so there's two parts of the cost. So I just want to clarify there is a cost in terms of the cost of every activity, every job that executes. That's being developed separately from the analyzer. We at the moment nothing. You won't find anything significant in 7.8. We've just got some fields within the work unit that records the cost, and it's all 0.0 at the moment. You'll notice in the metrics it will show the cost as 0.0 at the moment. And we have some internal changes within Roxy Thor that tracks the cost, but we don't have anything to configure how all these so it actually calculates the cost, but doesn't. We don't have anything available to configure the costs.
Yeah,
So
and that is fine. Yeah, it's still work in progress.
Yeah.
So that's the intention for the 710 series as well. So when is the target to have this with Ghost working for the users? It will be 712 or 8.0?
So 712. 712 is my target to have the first iteration of the cost. So that's reporting the cost. So the other part of the cost, as I mentioned, is actually suggesting the best structure of the in the cloud, the best sizing for the Thor job. So that's much further in the future. We haven't even scheduled that yet. So we need more information within the analyzer.
Yeah, that's a bigger effort. Okay, that's good. Hey, this has been great, Shamser. I really enjoyed this talk, and there is plenty of. At least I find this exciting. Maybe it's me, but both the analyzer and the costing information, which are so important for someone that is deploying. In some ways, without this type of tools, you are flying blind, right? You're deploying whatever you think you're deploying, and then just getting it to run, but there is no good feedback from the system. So having the analyzer to tell you that you have a work unit that has a significant skew in some place, or having the costing information to tell you, well, maybe you should use a different geometry in your cluster, or deploy this other way. It's extremely useful. I think it's going to be quite useful for everyone that's trying to use it in the cloud. So thank you very much. This was a great talk. And I think we need to do another one of these soon when you have a little bit more progress there.
Thank you, Flavio. It's been a good discussion.
Thank you very much. Thank you.